Hi, all of you. Good afternoon, online and offline. Good afternoon, all of you. Online students all have not come back from Holi, have they? है ना, होली लंबी चल गई या फिर रंग उतरा नहीं है, okay, मुंह दिखाने लायक नहीं रहे. वो तो खतरनाक स्टेटमेंट हो गया, मुंह दिखाने लायक नहीं रहे. ऑनलाइन स्टूडेंट्स, आप तो हमेशा से लायक हो, ये ऑफलाइन बच्चे नालायक हैं. This is the problem with breaks, you know. This is my experience. Hi Saurav, Jai Hind. Say aaj Jai Hind. Okay, fine. Jai Hind. When you take breaks, my opinion, breaks should not be more than 2 days, maximum 2 days. In most cases, your break should be half a day. Okay, half a day, because after the first day, वो एक आलस will start off. It's a fatigue thing. And getting back from fatigue is more tough, okay, than you otherwise thought. And I can vouch for this because, you know, some of you, if you are into exercise or jogging or into whatever, some bit of morning walks. I remember when I used to jog and do a bit of early exercises, the jogging part mein shuruaat is very tough. Getting up from the bed, getting ready, putting the shoes on, taking the staircase down, बहुत मुश्किल काम है. I mean, invariably you feel like यार आज रहने देते हैं, एक हफ्ता कर लिया, body बन चुकी, okay, एक दिन में क्या खराब हो जाएगा. Okay. But then you go down again with lot of motivation. You start the jogging part, start running. When you start running, dhire dhire, you know, it kinds of starts building up for you. अरे ये क्या हो गया? ऐसा क्या बोल दिया मैंने? Yeah. So it starts building up. After I think about maybe 50 meters, 100 meters, 200 meters की jogging के बाद में, then your body is active. You are running. You're running, you pick up speed. You come to a state which is in sports is called as reaching a high. When you reach a high, okay, उसके बाद even if the body is tired, every muscle screaming कि और नहीं हो पाएगा, but you can't stop. You feel like you're 20 meters more, 10 meters more. And in that run, अगर आप रुक जाते हो ना, then you can't run again. Then you stop, sit down quietly. And then you want to run again, it takes lot of energy again. So this is, I think, a pattern in any efforts. जब शुरू करते हो process, it's a, you know, you might make up your mind, I'll do it. But starting in the process is always tough. You know, पढ़ाई करना है. I don't know if I've tried this or not. पढ़ाई करना है, एकदम मन बना लिया, पढ़ाई करना है, आप टेबल पे बैठ गए, okay. उसके बाद, you know, अच्छा, book is here, not here, book is here, not here. आप पेन निकाल के, some of you will twirl the pen for 2-3 minutes. Okay, then you scratch your head, अच्छा, वहाँ पर एक और notebook है. The chair is rocking. The act of कि किताब खोल के चालू करो यार. Okay, the body will make good excuses. अच्छा, you know, lamp is not right. Okay, let me do this. Table आज पता नहीं ऐसे क्यों लग रहा है, ठीक कर देते हैं. Okay, oh, I can see यहाँ पर ऐसे fold हो गया है. All kind of excuses. Okay, and then slowly, चलो आप खोलते हैं किताब. खोलने के बाद भी you turning the pages, कहाँ से करूँ, नहीं करूँ. Okay, and then the process starts. So after half an hour maybe, some of you maybe a bit earlier, एक बार flow में आ जाते हो ना, then you lose sense of time. And same thing again, अगर रुक गए फिर, again getting back, it's such a tedious process. Say रुक के, okay, I'm tired, I'll stop now, I'll take a coffee break. वो coffee break कब lunch break होगा, कब वो evening snacks break हो गया, पता नहीं चलेगा आपका. And then coming back, जैसे एक technique है, I think Pomodoro technique, ऐसे ही कुछ technique है. That technique tells that every 15 minutes, 20 minutes, take a 5 minutes break. I personally could never do that. If I take a break, मतलब किताब बंद कर सो जाऊंगा मैं. And when I sleep, I don't take a nap. I sleep for 3 hours. You wake up and then feel guilty again. यार आज दिन खराब हो गया. नहीं, कल मैं ठीक है. आज चलो खराब हो जाने दो. Okay, कल दोबारा ठीक कर लूंगा. So I think it's a mind thing. Okay, so all of you, I'm just trying to tell this to you. जो होली से वापस नहीं आए, फिर उनको पता भी चलेगा मैं क्या बोल रहा हूँ. Don't take a break of more than 1 day. Maximum. अगर second day break होता भी है, find a way to read something. Maybe you'll slow. ठीक है भाई. Otherwise, I would have read maybe 2 chapters. I will read half a chapter. That's okay. Otherwise, I would have done 3 answer writing. चलो आज मन नहीं कर रहा है, 0 मत करना. I'll do 1 answer writing. Other days, maybe okay, I will write 4-5 synopsis. आज मैं एक कर लेता हूँ. Slow down the work, but don't stop the work. Stopping the work, I mean, becomes tricky for most of you. How many topics will be covered? मैं समझ नहीं पाया. Syllabus में जो कुछ है सारा cover होगा, unless you have not paid the fees completely. Okay, तो बीच में आपका काट देंगे हम. ठीक है. जब interesting बात शुरू होने वाला है, I'll start it and then, okay. Old movies में ना फूल दिखा देते थे. Okay. Just when you thought कि अच्छा अब कुछ होने वाला है, वो चिड़िया दिखा देगा. क्या today तो is more permissible. Okay. Okay, let's get back to our. Yeah, I belong to that generation. Okay. ये फूल देखते we used to smile. Okay. Okay. Let's start off. Geomorphology. So I have done 2-3 topics. Yes, Priyanshu, some of the topics I didn't discuss, I'll do it today. See, your main guiding format will be class notes, Priyanshu. If you want to go beyond class notes, fine, but not at the cost of the class notes. Extra पढ़ना चाह रहे हैं कि class note छोड़ क्या पढ़ाएगा वो ना करना. So, जो extra होगा, I'll tell you, and if you doubt, ask me. These topics I'll do it today. So, yesterday we discussed 2-3 things. We discussed what is the Earth's composition in terms of elements first, in terms of minerals next, in terms of rocks. Okay? The minerals I said are compounds naturally occurring in organic origin. They have a crystalline structure. There are groups of minerals, oxides, sulfates, carbonates, halides. Okay, the group of minerals, and the most important group of minerals, जो सबसे ज़्यादा common है, are the silicates. And silicates, I hope you now remember, or you have revised ones: quartz, feldspar, orthoclase, muscovite, biotite, amphibole, pyroxene, and olivine. Okay. So I remember this as Bapu. Bapu, इसको Bapu कर दिया इसने और क्या. So this part I would never forget quartz. I would never forget feldspar. तो fight मार लेंगे तो ओम भी याद हो जाता है. Okay. This was always confusing for me. Sequence क्या है? So my mnemonic for this was Bapu. Okay, BAPU और प्यार से बापू बुला दिया मैंने और क्या. Okay, so biotite, and biotite is the transition one, amphibole, pyroxene, and olivine. In this I had mentioned, the olivine is found mostly in the mantle, and olivine is part of a rock called as peridotite. That's the important common rock of the mantle. And rocks में igneous rocks, sedimentary rocks, and metamorphic rocks. And I gave you a quick list of properties also. Okay, made of sediments, it's softer, Metamorphic is dramatically transformed rocks. Metamorphic rocks because of high temperature, high pressure and so on. Igneous पे मैंने थोड़ा ज़्यादा ध्यान दिया है because I need the igneous rocks understanding to understand some of the landforms and processes of the earth. So igneous landforms, I said, okay, you can call these as plutonic. These are not stratified. These are crystalline. Okay, and depending on whether they are cooling inside the earth or outside, are they intrusive or are they extrusive? Okay, so we have large crystals or small crystals. Okay, we have pegmatites, we have glass. Glass is very, very fine crystals. Igneous glass, not the glass that we know of. Most of the glass we know of is synthetic है, हमने बनाया है out of some chemicals. The glass is as in igneous glass rocks. Okay, they look like without crystals, but actually crystals are very, very fine. So I gave you a name, obsidian rocks, right? Dragon glass, obsidian rocks. So that's about the igneous rocks. And one discussion we had for igneous rocks was the types of rocks according to the silica content, right? So felsic rocks and the ultra mafic rocks, and then we have intermediate here and mafic rocks. So if you remember the extrusive, intrusive, I had drawn this. This is granite. This is andesite, basalt, pedotite. और इसका equivalents है. Granite's equivalent is rhyolite. Andesite's equivalent is diorite. Basalt's equivalent is gabbro. इसका एक बड़ा unique सा है called as comatite. One reminder for all of you, memorizing these things का एक ही तरीका है, write it again. Write again, jot down again. Don't simply read. Okay, read once or twice, thrice, short recall and write down. If you write down 2-3 times, आपको याद रहेगा. And some cues like, ये diagram बना दिया आपने. See if you can use it to recall these topics. Okay? So I think you understand this. And then one discussion we had was that when we look at the felsic minerals, felsic rocks, and I grade towards ultramafic or ultramafic rocks and minerals, what happens is the density will increase in this direction. The hardness will decrease in this direction. It will become more and more darker in this direction. Okay. It will also become, the viscosity hai, will decrease. These type of rocks, these types of minerals are more viscous, they are more thick. The word viscous means the resistance to flow. These type of rocks and minerals are more viscous, they are more thick. They won't flow very easily. Whereas you move towards ultramafic, basalt, they are more fluid. They can easily flow and spread and form thin sheets, layers of rocks. Okay? So I believe no problems still here. Anybody, any questions you want me to clarify? I always insist, some of you do, otherwise don't. When I'm revising, I'll expect you bring your summary sheets with you. Okay, you go back to your room, make your summary sheets and bring the summary sheet to class. And while I'm recalling, आप देखते रहो, हाँ मुझे ये याद है, ये याद है, I remember this and so on. Yeah, Prachi, correct. Talking about the acidity, okay, the pH acidity, as I move in this direction, it will decrease. These rocks are relatively more basic. These rocks are relatively more acidic. All good, all of you? Any doubts on this? The type of minerals, the type of rocks. Then I was discussing internal structure. What does the arrangement of the layers look like? I said interiors are layered. Okay, there's layers. So one layer, a second layer, a third layer, a fourth layer, and so on. A layered interiors हैं. And in this layering, there are many models. So I was discussing the more contemporary, the more recent models under the chemical differentiation. Under the chemical layering, the chemical layers kya kya? What are the different layers of interiors in terms of the composition? When I say chemical, I'm talking in terms of the composition. So the layering is the crust, we have the mantle, and we have the core. The crust can be oceans, it can be continents. And I believe properties, oceans are soft, continents are hard, oceans are thin, continents are thicker, oceans are basic, continents are acidic, oceans, they are denser, continents are lighter. Is it okay, all of you? Okay, because of composition, continents are made up of andesite, granite, diorite, oceans are made up of basalt. So, जो भी basalt के properties हैं, basalt are thinner, basalts are softer, basalt is darker, basalt is more basic. Oceans, okay, oceans have the same property. And I said yesterday that why oceans are basaltic, ये हम बाद में कराएंगे. Abhi just remember that oceans and continents are two different layers of rocks. It's not that the continents extend into the ocean, ऐसा नहीं है. Continents का rock पूरा अलग है. So one of the old model was कि this is the rocks and the same rocks are everywhere. जहाँ पर गड्ढा है, water has accumulated and this is the ocean. So there is no difference between the continents, the oceans and again the continents. Now we know ऐसा नहीं है. The continents are different. The oceans are different. The oceanic rocks हैं, the oceanic compositions are not same as the compositions of the continent. Okay, so these rocks are granite rocks, rhyolite rocks, andesite rocks, diorite rocks. These rocks are basalt rocks. Continents are far more thicker, oceans are far more thinner. So oceans are not extensions of the continents, that's the point. Oceans are not the submerged part of the continents. Oceans are altogether different in terms of the origin, their formation, the structures and the features. Okay, so let's move on here. About the crust you understand, okay, oceans and continents. Mantle, we said there are three layers. Okay, the upper mantle, the middle mantle and the inner mantle or deep mantle. I gave a sense of the depth also. The upper mantle is about 350, 400 kilometers from the surface. The deep mantle starts from 1,000 kilometers from the surface. Have some idea about the values, okay? And the core finally is the outer core and inner core. Outer core starts from 2900, inner core from 4800. The outer core is fluid, it moves. The inner core is solid, iron, nickel. And this arrangement, के अंदर एक iron rich rock है. Around this, a very, very hot matter is moving, okay, which has loose electrons. ये जो arrangement है, this creates Earth's magnetism. So I'll come back and discuss again afterwards. This arrangement where the outer layers of the core, okay, or the outer core is a fluid, outer core is molten at very high temperatures with lot of loose electrons moving, okay, and inside is an iron rich, ये iron important है, iron rich, nickel rich core, solid core है. ये जो arrangement है, this creates the magnetism of the earth, properties of the geomagnetism. Check all of you. Any questions still here? Anybody any doubts on this? All good? Okay, then let me add something now. So what we know is that this is the crust, this is the crust, and these are the mantle layers. These are the mantle layers. And then we have the outer and the inner core. Upper mantle, middle mantle, inner mantle, outer core, and inner core. Now, between these layers, ये जो zone है, okay, this one here, there is one which is here, there is one which is here, और भी हैं, okay. These are the main ones. We call these as discontinuities. We call these as, okay. So somebody asked me, what is discontinuity and why do we call them like that? Essentially, it's like, imagine my palm, or imagine the book and my palm. Palm is living cells, palm is skin, palm has tissues, the book has paper or some other material, and I am putting them together. No matter how closely I fuse them, the fact is there is some place where the skin ends and the book starts. Jitna bhi aap mila lo. Okay. Some place where the skin jo continuous hua karta tha will break, will stop, and the book will start. That is called as discontinuity. So actually, discontinuity alag se layer nahi hai. Understand this. It is just where one layer ends, another layer starts. People make a mistake of calling this as a layer. It's not a layer. It is the depth where one layer ends and another layer starts. So same layer, continuously, same layer, continuous, discontinuous. Okay. Now another layer, same layer, continuous layer. It stops, discontinuous. I hope you got the point here. So discontinuity is actually not a layer. It is the depth where one layer ends and another layer starts. ऐसे बहुत सारे layers हैं, but the 4-5 of them which are more popular is, okay, number one is between the crust and the mantle. Between the crust and the mantle, okay, this one here, this is called as Mohs continuity, Mohs discontinuity. Mohs discontinuity. It's a Russian name, Morovisic, or we call it as Mohs. Okay, you remember it says Mohs discontinuity. That's one. Then this is two, between the middle mantle and the inner mantle. Okay, this is at around 700-900 kilometers. We call this as Repiti. Some books they mention as the birch discontinuity. Then we have between the inner mantle and the outer core. This is at around 2900 kilometers. We call this as Gutenberg weight chart, Gutenberg's discontinuity. And the fourth one, this is between the inner core and the outer core at a depth of 4800 kilometers from surface. We call this as layman's discontinuity. In fact, these are the people who discovered the different layers of the earth. ये चार मेन है, चार में एक और ऐड कर सकते हैं. There's one discontinuity within the continent. It varies at a depth of around 30 kilometers. In some place it can be deeper. This is only within the continents. Okay, this I can call it as 5. It's called as the Conrad's discontinuity. Okay, it's called as the Conrad, C-O-N-R-A-D. So all of you have a look at this. Yeah.
So this Conrad is between the continental crust and
No. It is within the continents. आप जो कहना चाह रहे हो वो शायद यहाँ पर होगा, नहीं. Within the continents. देखो, पर लिख लो. Do this jotting first, then I'll explain something more on that. The different discontinuities. Give heading: discontinuities of the Earth's interiors. They are the depth where the different layers get separated. The discontinuities. Okay. मोहो का कोई एक depth है नहीं. When oceans are there, the moho is at a lower depth. When the continents are there, is thicker, moho will be a bit more deeper. So the moho's depth, the depth varies. The depth from the surface, it varies. It is deeper under the continents, it is shallow under the oceans. Moho's discontinuity has different depths. It is deeper under the continents and it is shallow under the oceans. Yeah, Priyanshu, ab बाकी जो आपको शब्द यूज करना है करो आप. Okay, that's okay. Understand this. See, I don't expect any questions on this in your optional. Okay, these are facts you should know. And अगर पूछता भी है, maybe they'll ask you moho in the prelims. And when they ask you a discussion in general, write about the Earth's interior, so एक paragraph बनेगा. I don't expect to write a note on moho or write a note on Conrad. It's very, very less likely. But these facts are there. You should know these facts as a geography student. All done, all of you? So your friend was asking us, what is this Conrad thing? Dekho, you're talking about a continent. You're talking about a continent which is enormous. Okay, I'm talking about continents which have a thickness of 60 kilometers. In some places, the thickness can be even 80 kilometers. इतने ज़्यादा thick continents में, the rocks which are here are not same as rocks which are here, right? As I go in the upper parts, the rocks become more and more acidic. In the lower parts, the rocks are less acidic, they're more like basic, right? Remember, we have got felsic rocks and we have got mafic rocks. We have said the oceans are mafic, the continents are felsic. Within continent also, the above layers are more felsic, the lower layers are relatively more mafic. I'm not comparing this mafic and this mafic. Okay, I'm not comparing this is like ocean, aisa nahi hai. But if I compare this and this, so these are rocks called as A, these are rocks called as B, these are rocks called as C. Okay, the B rock जो काफी depth में है, they will be more like C rather than being more like A. Okay, so in books they mention there is some layer at a depth of 30 kilometers within the continents that separates the upper felsic from the lower mafic. But don't consider this mafic as oceans. Oceans ऐसे continuously ऐसे है नहीं. It's not like this. Oceans are a separate layer altogether. Is it okay, all of you now? ठीक है? So add कर लो in your notes Conrad. The man discovered this is Conrad, C-O-N-R-A-D. Conrad's discontinuity at around 30 kilometers from the surface. Conrad's discontinuity at around 30 kilometers from the surface separates the upper felsic from the relatively lower mafic. Separates the upper felsic from the relatively more mafic layers within the continents. Separates the upper felsic from the relatively more mafic rocks within the continents. So Conrad is only found in the continents. We don't have Conrad in the oceans. Is it okay, all of you? So what are the discontinuities? Conrad, Moho, talked about Repiti or Birch, Gutenberg, and we have the Lehman's discontinuity. Okay, put a star mark. All the discontinuities are density discontinuities. All the discontinuities are density discontinuities. का मतलब क्या है? That they separate rocks of some density from rocks of some other density. Dramatic change होगा. The rocks which have some value here in density, the rocks here, काफी difference होगा. Okay. So they are called as density discontinuities. However, Lehman discontinuity and Gutenberg, Lehman, L-E-H-M-A, Lehman is between inner core and outer core. Lehman discontinuity and Gutenberg, G-U-T-N-B-E-R-G. Lehman's discontinuity and Gutenberg's discontinuity are also called as phase discontinuities. They are also called as phase, P-H-A-S-E, phase discontinuity. Why? Solid phase from liquid phase. Like they separate the solid inner mantle from fluid outer mantle. They separate the fluid outer mantle from solid inner mantle. So phase means the state of the matter. वो liquid है या solid है. So Gutenberg and Lehman's are also called as phase discontinuities. All done? Yeah, any doubts in this? Anybody? Any doubts in this? Conrad, Suman, Conrad. Okay. So I think your fact is done. Now let me take up the other discussion. So chemical layering I'm done. We have the mechanical differentiation. Mechanical differentiation. Mechanical differentiation is in terms of a relative hardness. It is on the basis of a relative rigidity, not in terms of composition, but in terms of rigidity. Okay? So one example I give commonly to students is, think of your wall. Okay, the wall has bricks. ब्रिक्स के ऊपर में एक लेयर ऑफ प्लास्टर है, उसके ऊपर में एक लेयर ऑफ मे बी पीओपी है. ओवर दिस देयर इज सम पेंट और डिस्टेम्पर, राइट? देयर इज अ ब्रिक, देयर इज प्लास्टर, देयर इज पीओपी, gypsum layers or some plaster POP, and there is paint here. Okay. Now the way they are fused, in all likelihood you cannot remove, or maybe above the POP एक और layer हम रखते हैं called as primer बोलते हैं, one more layer called as primer, and then maybe we have the paint. ठीक है? The layers are so fused, while you can separate the brick from the plaster, you can't separate the paint and the primer. Sometimes you can't separate the paint, primer and the POP. आप इसको तोड़ोगे ना, पूरा टूट जाएगा. So even if the compositions are different, paint का अलग composition है, primer has another composition, the POP is another composition, but the way they are fixed, okay, they act as one layer. Whereas these two are different, of course. Plaster and bricks, you can separate them. So if you look at the Earth's interiors, even if these are distinct in terms of composition, some layers are so well fused, you cannot separate part of the crust from the part of the upper mantle. Okay, you cannot separate some of the layers underneath either. So when I say rigidity, I talk in terms of how well some layers act as one layer. So under this scheme what we have is, so all of us understand there is continent, there is ocean. There's ocean. Then there is the upper mantle. Then there is the middle mantle, the inner mantle, and the core. This we understand. Okay, this is now in the chemical layering. What happens is that this is the upper mantle. The upper part of upper mantle, ye pura thing, acts as one unit. You cannot separate the oceans, the continents, and this upper part of upper mantle up to a depth of 100 kilometers. ये layer को हम बोलते हैं, we call this layer as the lithosphere. And the remaining जो है, this remaining part is called as the asthenosphere. तो asthenosphere जो है, it is essentially a part of the upper mantle. ये पूरा का पूरा upper mantle है. This is the upper mantle. This is the lower upper mantle. So this is one layer. This is another layer. Okay, and this whole thing is called as the mesosphere. Meso as in beach mein. Mesosphere is the middle mantle along with the deeper mantle or inner mantle, and the core is referred to as the barysphere. Okay, so in terms of rigidity, okay, there are these four main layers: the upper lithosphere, the asthenosphere, the mesosphere, and the barysphere. Upper mantle, lower upper mantle. This is the outer core. This is the inner core. Draw this sketch, then I'll give you some points. The layering of the Earth's interiors on the basis of relative hardness or relative rigidity in terms of mechanical strength. इसीलिए हम बोलते हैं mechanical differentiation. In terms of mechanical strength or mechanical differentiation. All good? So write down. There are four layers. Number one, lithosphere. There are four layers. Number one is lithosphere. Okay. The lithosphere is okay, the crust along with the upper part of upper mantle. The crust along with the upper part of upper mantle for a thickness of about 100 kilometers. In the lithosphere, the crust and the upper part of upper mantle, the lithosphere, and in the lithosphere, the crust and the upper part of upper mantle act as one rigid unit. They act as one rigid unit. In the lithosphere, the crust, when I say crust, I mean both oceans and continents together. The crust, okay, the crust along with the upper part of the upper mantle act as one rigid layer. You can't separate them as easily. They act as one rigid layer. Okay. it is cold, and it is brittle. It is brittle, B-R-I-T-T-L-E. It is cold and it is brittle. What's the meaning of the word brittle? Anything which can break very easily. Okay. Opposite of brittle is ductile or malleable. You can stretch it, you can bend it, you can draw into wires, into sheets. Okay. Brittle को आप deform नहीं कर सकते. What's brittle will break. Think of papad. Think of your roti and papad. Okay. Roti is heavier than papad, but papad is brittle. Okay. हल्का सा apply करोगे pressure, it will break. So the lithosphere, okay, is brittle. It breaks when you apply pressure. Continue. The lithosphere is not a continuous layer. It is broken into segments. The lithosphere is not a continuous layer. It is broken into segments called plates. It's broken into segments called plates. Okay? So if you look at the lithosphere, so imagine this is the lithosphere, a big large block like this, which has continents and oceans. This is the lithosphere. What I'm saying is, the lithosphere एक layer नहीं है, ऐसे टूट गया, it's broken here. It's cracked. It is broken here. It's cracked. Okay. It is cracked like this. Okay. So these blocks are called as the lithospheric plates. Okay. जिसमें कि there's a continent part, there is an ocean part, okay, and there is the upper part of upper mantle. There is an ocean part, there is a continent part, and the upper part of upper mantle. Okay, the continents and the lithosphere, okay, they are part of the layer. The oceans and lithosphere are part of the uppermost layers. Okay, they are broken into pieces called as plates. The second layer is the asthenosphere. The second layer is asthenosphere. Asthenosphere is the lower part of the upper mantle. The lower part of the upper mantle. From about 100 kilometers depth to about 350-400 kilometers depth. From about 100 kilometers depth to about 350 or 400 kilometers depth. I hope you remember the upper mantle is till how much? Around 350? 400 tak hai upper mantle. The middle mantle is still 700-900 kilometers, and this is 2900. Okay, and I'm saying this is up to 100. So from 100 depth up to 350-400 ka depth, this is called as the asthenosphere. Write down. Asthenosphere is predominantly peridotite rocks and olivine minerals. It is predominantly peridotite, P-E-R-I, peridotite rocks and olivine minerals. वैसे तो मैंने कहा कि पूरा का पूरा mantle is olivine, but I made one qualifying statement yesterday was कि olivine and its variants. Okay, there are other types of olivine also. Okay, but the asthenosphere is the olivine that we know of. It has predominantly olivine minerals and the rock called as peridotite. Write down. Because of olivine, which has a peculiar property, a very unique property of losing rigidity under stress. It loses rigidity under stress. Under stress. The asthenosphere is not a regular type of solid. The asthenosphere is not a regular type of solid. It is mobile and can flow. It is mobile and can flow. When there is pressure. When there is pressure. ठीक है? So olivine का एक property है. Olivine is solid. It is solid. But when you apply pressure on this, when you apply stress on this, when you apply pressure, the solid will now start to flow. ऐसे बहने लगेगा. It will become something like a liquid. Remove the pressure, it will again become solid. So I think for imagination, think of sponge. Okay. So if you apply, sponge is solid. You apply pressure, the sponge can get deformed. Remove the pressure, it again becomes the old shape. So think of something of that kind. Because we don't have another good word for this, so we use the word, it is semi-molten. People make a mistake of imagining semi-molten as the liquid that flows. ऐसा नहीं है. It's just another convenient word. Okay, we don't have a better word. Okay, in regular physics, this type of material is not common. So, as a compromise, we use the word that it is semi-molten, implying it is not a liquid, but it can behave like a liquid when there is a pressure. Is it okay, all of you? So, yes. Okay. So, within bracket mention, okay, the asthenosphere supports the lithospheric blocks or plates. The asthenosphere supports the lithospheric plates that float over it. It supports the lithospheric plates that float over it. Okay, and put a star mark. Put a star mark. This arrangement and this concept is the basis of the modern theory of plate tectonics. ये जो concept है, that the asthenosphere is like a liquid, the plates are moving over it, they're like floating. The lithosphere is okay, a hard, rigid layer which is broken. This arrangement of the layers, this concept of how the layers are arranged, that is the basis of the modern theory of plate tectonics. Is it okay, all of you here? What is the theory of tectonics? उसका roots जो है इसी concept पे. ठीक है? Okay, let's move on. So, बाकी layers में just mention. The third layer is the mesosphere. Mesosphere is the middle mantle and the inner mantle. And the fourth layer is the barysphere. Nothing much to know about this. Just know that this is another scheme altogether. The third layer is the mesosphere and the innermost layer is the barysphere. Okay, nothing more to add, okay, over and above this. Okay. Now, for the sake of, some enrichment, there are other models. So, I'm done with the contemporary models. There are other models of Earth's interiors. The other models of Earth's interiors. Okay. This will be your work, but I'll tell you basically kya hai. No questions from this, just know the concepts. Other models mein, we have book में आपके 3 मॉडल मेंशन है. One is the model given by Edward Swiss. ये सब अर्लीस्ट मॉडल्स हैं. एडवर्ड स्वेस हम बात कर रहे हैं 1830s 1840s की बात हो रही है. Pretty old model. One of the first model, in fact, Edward Swiss model. Then we have a model given by Arthur Holmes. Arthur Holmes, okay, 1920s 1930s की बात हो रही है. Arthur Holmes. Okay, and one more model given by, okay, Van der Gracht, Van der Gracht's model, Edward Swiss model, Arthur Holmes model, and Van der Gracht's model. So they said the Earth is 3 layers. There is an outer layer, there is an intermediate layer, and there is an inner layer. Okay. The Earth has 3 layers. Okay. अलग अलग लोगों ने अलग अलग नाम दिया हुआ था. Okay. Edward Swiss called the outermost layer as the Sial layer, the intermediate layer as the Sima layer, and the innermost layer as Knife. N-I-F-E. Short form of all the elements. Sial is silicon and aluminium. This is silicon and magnesium, and nickel and iron. Sial represents the continents, Sima represents the oceans, and Knife represents the core. Okay? Yeah, please keep writing. Okay. Keep writing these points down. Edward Swiss, E-D-W-A-R-D. Edward Swiss, S-U-E-S-S. Edward Swiss. Arthur Holmes, A-R-T-H-U-R. Arthur Holmes. And Van der Gracht, G-R-A-C-H-T. Van der Gracht. Yes? हाँ, इन्होंने कहा था. Oceans and mantle. Oceans and the mantle. दोनों. For him, the ocean is the exposed part of the mantle. ठीक है? And these are all wrong concepts. Elementary school level में अभी भी हम पढ़ाते हैं एडवर्ड स्वेस का Sial, Sima, Knife. But this is not the best concept. The best concept is now crust, mantle, and the core, or lithosphere, asthenosphere, and the other layers. Sima is the ocean. Sima is also the mantle, according to Edward Swiss. Arthur Holmes, okay, he called the outermost layer as gran diorite layer. Then we have amphibolite layer, and we have the ecolgite layer. Ecolgite is something like the deep mantle and the core. The grandiorite layer, the amphibolite, as in more of amphiboles, amphibolite layers, and the ecolgite layers, E-C-O-L-G-I-T, ecolgite layers. Grandiorite implying granite and diorite. So grandiorite is something like the continents. It's something like the continents. Again, I repeat, don't try to look for proof of this. Just must know some names. Details भी ignore कर सकते हो. If you are curious, is there in the book, but I am skipping all the details there. And the third one, Van der Gracht's model, he said the outermost layer are the outer silicates. These are the outer silicates. Then we have, okay, the intermediate mein, there are 2 layers. We have the inner silicates plus a layer of mixed silicates. And the deepest part, okay, this is the metallic core. Okay, so outer silicates, intermediate mein there are two types, the inner silicates and the mixed silicates. Mixed basically means यहाँ पे metals भी हैं. It goes to your deeper mantle parts. Outer silicates, inner silicates, mixed silicates, and the metallic core. And the metallic core. So आपके textbook में, I think it's page 10108, 1009, okay, or 1010, where your core mantle started. लिख लो, refer Savindra Singh Geomorphology, page 109, 110 or 111, around that page होगा आपका. ठीक है? ज़्यादा book research मत करना, okay? I am deliberately being very selective. In fact, one student asked me, sir, पूरा पढ़ ले तो अच्छा है. मैं कहा अच्छा तो है बेटा, but exam के लिए अच्छा नहीं है. Okay, अच्छा है, आप ज्ञानी बन जाओगे, ज़्यादा जान लेंगे आप. Our purpose is how to crack the examination. और extra पढ़ना ही है. There are many other things to read. पहले वो खत्म करके फिर इसमें वापस आओ. ठीक है? GS करना है, current affairs करना है, make notes, वो सब छोड़ छाड़ के read something else which is not as important, you'll only trap yourself. Okay, this is enough for us as of now. The different models, okay, but the most contemporary one is the crust mantle core or the lithosphere, asthenosphere, and the barysphere layer. All good, all of you here? Okay, let's move on. Now this is an important topic. इससे questions आए हैं एक दो बार. What are the evidences of the Earth's interiors? What are the evidences of the Earth's interiors? This is important for GS, also important for your optional. Okay, GS में इस topic से there have been prelims questions asked. Okay, एक दो आप पूछा हो. Last year they asked one question on P waves and S waves. In the optional paper, they can be proper question. हालांकि in recent time, they haven't asked too many questions on this, but this is a possible question. What are the evidences of Earth's interiors? You know, so Earth's radius is 6400 kilometers. Okay, it seems impossible to ever reach the core physically. Okay, Earth's interior is 6400 kilometers. It's almost impossible. Even if I talk about the more optimist, अगर जाना ही है तो मार्स जाओ. Okay, with Elon Musk is trying anyways. खोद के गड्ढा क्यों बना रहे हो? That's the whole idea. So very unlikely that we can reach the core physically. Okay, the deepest mines are 3 to 5 kilometers, and the deepest drilling is about 10 to 12 kilometers. You're drilling through the interiors. Okay. So this drilling is done for oil. There is this Russia में area है called as the Kola Peninsula and the Barents Sea. काफी न्यूज में they're part of the Arctic zone. The Kola Peninsula, Kola, Kola Peninsula and the Barents Sea. यहाँ पर oil है, and Russians have gone deep as much as 12 kilometers drilling they have done. But 12 kilometers be nothing. You are barely scratching the surface of the continents. Continents अपने आप में 30, 40, 50 kilometers deep. 12 is all as good as nothing. So I'm establishing that it's almost impossible to reach the interiors of Earth. So we rely So we rely on different evidences to know and to understand the interiors. Okay, we rely on different types of evidences to know and understand the interiors. Okay, evidences क्या हैं? What are evidences? Evidences is the study of volcanic rocks, the study of rocks in the mines, the study of rocks or the sediments from the drilling sites. We study the volcanic rocks, volcano से बाहर आ रहा है, अंदर वैसे ही होगा कुछ और क्या. Study of volcanic rocks, study of rocks at the mines, you're digging the mines and studying the rocks. Study of the rocks and the sediments at the drilling sites. आप drill करके निकाल रहे हो, drilling sites. ठीक है? So this tells us, in fact, just know this, in 1960s में, we had a very famous project called as the Geoids expedition. It was a project for drilling the ocean floor. Geoids इसी का एक और part था called as Deep Sea Drilling Project, DSDP. Okay, so they have been doing something. They have been drilling the ocean floor. Geoids, Joides, Geoids expedition, and the project called as Deep Sea Drilling Project. So in these, we know something about what the interiors might have. Study of volcanic rocks, the study of rocks, the mines, study of drilling. इसके अलावा, we also have observed mantle rocks at deep ocean trenches. We've observed mantle rocks at the deep ocean trenches. I hope some of us know this. A trench क्या होता है? Trench is a very deep depression, where there is some lithosphere here, another lithosphere here, there's a gap here. For some reason, this lithosphere can go inside the mantle. This is lithosphere 1, lithosphere 2. इनके बीच में एक gap है. The gap is called as the trench. It's not like a river valley. It's like a gap. And through this gap, it is possible to access and study the mantle rocks here. When I'm saying see the rock का मतलब नहीं कि जाके पहुंच के आपने पानी हटाया और झांके देख लिया. ठीक है? So it's not, when I say see, I mean they still are using instruments. They have got spectroscopes, they have got some radio sensitive telescopes maybe. They study the spectral range and radiations maybe. So at the trenches, the gap is called as trench. Ye trenches are on the ocean floor. So within bracket mention, trenches are gaps. Within bracket mention, trenches are gaps. Gaps between lithospheric plates. The gaps between lithospheric plates where the ocean floor is sinking into the mantle. The gaps between lithospheric plates where the ocean floor is sinking into the mantle. This sinking process ko, some of you might know, it's called as the process of subduction. So the ocean floor is going inside, अंदर जा रहा है. This is the mantle. So ये जो gap is called as a trench. And write down that trenches are always on the ocean floor. The trenches are always on the ocean floor. On the ocean floor. The trenches are gaps between lithospheric plates, the locations where the lithosphere, ocean lithosphere, is sinking inside the mantle. Okay. और ये gap कहाँ होता है? Ocean floor पे होता है. So I think you know about a very deep trench called as, yeah, the Mariana Trench. The Mariana Trench का जो depth है, it's approximately 12 kilometers deep, the deepest depression on the earth. वैसा ही एक trench है in southern Atlantic. It's called as the Scotia Trench. Sorry, it's called as a South Sandwich Trench. Okay, write down this point. At the South Sandwich Trench, at the South Sandwich Trench, bordering the Scotia Plate, at the South Sandwich Trench, bordering the Scotia, S-C-O-T-I-A, Scotia Plate, the mantle is partially, within commas likho, partially visible. The mantle is partially visible. Visible, it's more in the literal, more in the metaphorical sense. Not that I can actually see it. Okay, there are radiations coming from there. There are some radio telescopes attached there. They study energy coming out rather than actually seeing the mantle. ये कहाँ पर है Scotia Plate? Scotia Plate is in South Atlantic Ocean. It is in the South Atlantic Ocean. So if you all have seen South America, this is South America, Brazil, Peru, okay, and south of this we have the continent of Antarctica here. So somewhere here, okay, यहाँ पर एक छोटा सा plate है. This is called as the Scotia Plate. It's called as Scotia Plate. S-C-O-T-I-A, the Scotia Plate. No. ये सारे टेक्निकल वर्ड्स हैं, इसको आप छेड़छाड़ नहीं करोगे. Okay, so a dog is not a small tiger, okay, because it has 4 legs. Okay, we will not make that mistake. ठीक है, तो ये सारे टेक्निकल वर्ड्स हैं. वैली क्या है, गॉर्ज क्या है, कैनियन क्या है, ज्योसिंक्लाइन क्या है, ट्रेंचेस, all are different words. Will not use one for the other. Simply, they are depressions. They actually are gaps between lithospheres. The locations where ocean lithosphere is sinking into the mantle, okay, and there is some gap, okay, which can help us study. So यहाँ पे एक trench है called as the South Sandwich Trench. All fine? See, one very important aspect of geography, या सब याद रखना आप, you have to give names and places in reference. Otherwise, geography है नहीं. Otherwise, general है. How do you know about the interiors? Because of drilling. How do you know about the interiors? Because of volcanism. छोड़ दो उसमें. But if I am specific, drilling at the Kola Peninsula, mining, very deep gold mines हैं in Johannesburg, in South Africa. Okay. Trenches, where at the South Sandwich Trench. So when I add locations and places, and if time permits, a small diagram and a sketch, that gets you marks. Don't just say we have urban floods. फिर specify करना कि कहाँ पर urban floods. Say Mumbai का कहाँ पर? Which part of Mumbai? Which district of Bangalore? Which part of maybe northern plains? So if you can mention the specific locations, that's when it becomes more of geography. Okay? So these names are not trivial names. You are supposed to use them as and when required. Okay? So how do we know about the interiors of Earth? We know about the interiors of Earth by studying volcanic rocks, by studying the rocks at the sites of mines. There are some deep mines. By studying the rocks from the drilling locations, and by studying the rocks or whatever composition at the trenches. इसके अलावा, the next one. I hope you numbered this, right? 1, 2, 3, 4. This is 1, this is 2, this is 3. The fourth one is The mantle wala, the fifth one. Yes. The lower upper mantle. अब वो कौन सा डेप्थ है? I think upper mantle का ही part होगा. Okay, it's not really lower upper mantle. Okay, वो कौन सा part exactly? I can't be specific there. Okay. Your logic seems right. Astronosphere का शायद part होगा. Okay, or part of upper mantle, yes, but I can't be sure about that. Okay, write down next. Next is study of. The next is the study of meteorites. The study of meteorites. I believe you understand this. Okay, the meteorites impact the Earth, and Earth has been made by the same process that has created all other planets and celestial bodies. So Earth एकदम अलग नहीं हो सकता, कुछ ना कुछ तो होगा Earth and other planets में. So when I study the rocks of other meteorites, okay, I can have an assessment कि Earth पे भी ऐसे ही कुछ होने वाला, nothing else. Okay, so meteorites is one type of, you can say, inference about what the Earth may have been when it was forming. Okay. Now these type of studies are called as direct study, because आप actually study कर रहे हो directly the volcanic rocks, directly the rocks of the mines, directly I'm studying the radiations at the trenches, directly I'm studying the meteorites. But there are other studies called as indirect studies. There are certain indirect studies. इसके अंदर में there is a gravity study, there is density study, and there is a seismic wave studies. Indirect studies, there are gravity studies, there are density studies, and there are seismic wave studies. Okay, I mean, don't write this down. Look at this here. देखो, say Earth, and we know Earth has mass. Because of Earth has mass, Earth will have a gravitation attraction. Okay, because Earth has mass, I am calculating the gravity force here, the gravity force here, the gravity force here, the gravity force here, and I find there are variations. If this area has lesser gravity, I can conclude that maybe the rocks here are not as dense. ज़्यादा mass है नहीं. This area gravity बहुत high है in comparison. So maybe this part has rocks which is more denser. That's how I study the variations in gravity and conclude something about कि अंदर क्या हुआ होगा शायद. The same thing applies for density also. I study density here, how Earth spins, and some understanding. So these two, just know that they are one types of inferences. Details ignore karo. This is where I need the answer to be. Write down. Density studies and gravity studies. Density studies and gravity studies can be fair indicators of variations of mass, can be fair indicators of variations of mass in the interiors. Variations of mass in the interiors. This can help indicate variations in composition. The indicators of variation of mass, and in turn it can indicate the variations in the composition. The most reliable studies are studies of seismic waves. The most reliable studies are the studies of seismic. Seismic as in earthquake waves. These are the most important studies. These studies are almost confirmatory. हमें ज़्यादा doubt नहीं रहा. They are so reliable that they are almost confirmatory studies about the interiors of the earth. The seismic study or the earthquake wave studies. All fine? Okay, fine. Now, so give a heading, seismic waves. Seismic waves. Okay? The seismic waves क्या हैं? They're essentially waves that help energy movement. The waves are associated with how energy moves. Okay. जो energy होता है, it can move by what's called as electromagnetic radiations. Think of gamma rays, think of X-rays, think of ultraviolet. ये सारे जो हैं electromagnetic radiations हैं. Okay? Energy can move in terms of electromagnetic radiations. When I use the word radiation, it does not need medium for propagation. It can move without a medium. It does not require a body to pass through. I think most of us understand this concept. Radiations can pass without the need of a body. A body ho na ho, the energy can pass. Gamma rays, X-rays, infrared rays, वो अलग-अलग type का waves हैं that require different type of conditions. Energy can pass through mechanical waves. Mechanical waves are those waves that require energy to move. There are electromagnetic waves that don't require a medium. There are mechanical waves that need a body, that need a medium to pass. Mechanical waves, they need a body, they need a medium to pass. ठीक है? And the behavior of the waves, how the waves behave. They go fast, they go slow, they turn, they reflect, they bend. The behavior of the waves depends on the medium through which they pass. ये बहुत important concept है. The mechanical waves need medium to pass, and their behavior depends on the medium through which they pass. And their behavior depends on the medium through which they pass. So what do I mean by this? What I mean by this is, ये कोई body है. There's one energy that doesn't care. Body है नहीं है, वो pass हो जाएगा. Worst case में pass करके absorb हो जाएगा. But it does not require the medium. एक और energy है. It enters the body, it starts behaving in some ways. It enters the body, it starts behaving in some ways. It enters the body, okay, it starts modifying in some ways. ठीक है? By studying this behavior, I can find out ये body क्या था. If it moves like this, the body is X type of content. If it moves like this body is Y type of composition. If it moves like this is Z type of composition. So the mechanical waves are those waves that need a medium to pass, and when they are passing, they get modified because of the property of the medium. Therefore, if I know the behavior, so क्या है इसमें क्या है? Okay, the behavior of the wave depends on the medium, and therefore, if the behavior of the waves is known, the medium can be inferred. Is it okay, all of you here? Okay. If this is the wisdom, that because the wave's behavior depends on the medium, if I was having some mechanism to know how the waves are behaving, I can guess what the medium is. If the behavior of the waves is known, the mediums can be inferred. The mediums can be inferred. ठीक है? तो यहीं पर आता है seismic wave का study. Okay. So in earthquakes, there are some waves which are mechanical waves. Write down. At earthquake events, there are certain types of waves. That propagate through the interiors of the earth. There are certain type of waves that propagate through the interiors of the earth, and their study helps us, know about the interiors of the earth. Their study helps us know about the interiors of the earth. ठीक है? So put this in a box. This is the main discussion point that we required. ठीक है? So ये अर्थ है. Somewhere here earthquake happened. Some energy has passed, but this is electromagnetic energy. तो ये मेरे काम का नहीं है. There's some other energy passing, which is the mechanical wave. Mechanical waves में क्या होता है? There are vibrating particles. Okay. These are radiations. इसमें कोई particles नहीं होता है. The radiations, they pass, and I don't need this one for my study. Mechanical waves have vibrating particles. उनके कुछ behavior होते हैं. By studying those particles, I can tell कि अच्छा यहाँ पर there was material A, यहाँ पर there was material B, the rock here was a rock type of C. How they know the behavior here, that's beyond our scope. Geologists have some technique, they have some instruments. वो कह रहे हैं तो मान लेते हैं और क्या? I mean, झूठ थोड़ी बोल रहा होगा, ठीक ही बोल रहा होगा. So we skip that part. We just study the inferences. कि what are the interiors? Okay, the way we know it because study of the earthquake waves. Is it okay, all of you here? Okay. So seismic or earthquake mechanical waves. the earthquake or the seismic mechanical waves. Okay, before I move on, do you have any doubts to clarify, anybody? Yahan tak? Any doubts you want me to clarify or explain or discuss? Turn your pages, because this is the small technical part which some of you might get trapped. Any questions, ask me. आपको मैंने 4-5 वर्ड बताया. There is radiation, there is a medium, there are mechanical waves, and mechanical waves have vibrating particles. Radiations में ऐसा नहीं होता, तो हम इसकी बात कर रहे हैं. The mechanical waves, the particles are vibrating, they're passing through some medium, and some behaviors you will see. Any questions on this? Yes. क्या जानना चाह रहे हो, बताओ उसमें. हाँ, तो there's a nature. I said, is imagine this like a balloon. Okay, balloon, solid. Okay, if you press it, वैसे फैल जाएगा. Remove the pressure, it again comes back. Like a sponge, squeeze it, it'll deform. Remove the pressure, वापस ठीक हो जाता है. तो astronosphere ऐसे ही कुछ है, सोचो. If you apply pressure, you apply stress, it will start flowing. Remove the stress, it'll again bounce back. I'll come to that, Akash. I've not come that far. Anybody else, any queries online? Any doubts on this? Examples of mechanical waves is sound wave. Any wave which is associated with vibrating particles. Okay. The sound wave is a mechanical wave. When you have hold a guitar and you pluck the guitar string, that's also mechanical. You can see the wires vibrating and moving. It looks like it's moving. The sea waves are also mechanical waves. जिसमें कि particle vibrations हैं. So Priyanshu was asking me what are the examples of mechanical waves. Plucked guitar string, sound waves, the ocean waves are all examples of mechanical waves. ठीक है? Anybody else? Seismic wave में electromagnetic भी होता है. Okay, but हम उसको नहीं पढ़ रहे हैं. हम पढ़ रहे हैं वो कंपोनेंट जिसमें कि वाइब्रेशंस हो रहे हैं. एनर्जी जब आ रहा है ना, एनर्जी के बहुत सारे फॉर्म्स. इट्स लाइक, आई हैव स्ट्रक अ मैच. बिकॉज द मैच, यू कैन सी द एनर्जी कॉल्ड एज साउंड. कुछ आवाज हुआ. आई कैन सी एनर्जी कॉल्ड एज लाइट. आई कैन सी एनर्जी कॉल्ड एज हीट. बट मैं शायद हीट पढ़ रहा हूं, बाकी को छोड़ दो. ठीक है. एनर्जी कैन हैव डिफरेंट फॉर्म्स. ठीक है. सो अर्थक्वेक वेव्स में भी, अर्थक्वेक एनर्जी में भी इलेक्ट्रोमैग्नेटिक वेव्स भी आता है एंड पार्टिकल वाइब्रेशन भी होता है. हमारा मकसद है टू स्टडी अर्थ इंटीरियर्स. ओके. सो आई विल स्टडी दोज वेव्स विच डिपेंड ऑन द मीडियम. इलेक्ट्रोमैग्नेटिक छोड़ दो, अभी हमारे स्कोप में नहीं है अभी. ठीक है. Okay, so let's move on. So seismic waves, जो mechanical waves हैं, ये waves again two types के होते हैं. Let me give you a schematic here. There is earthquake energy. Earthquake energy can be electromagnetic energy. It can be mechanical energy. हम इसको छोड़ दे रहे हैं, हम इसको पढ़ रहे हैं. मैकेनिकल एनर्जी कैन बी surface waves, they can be body waves. Okay, so I have earth here. This is the earthquake point. Because of earthquake, एक energy surface move ऐसे कर रहा है. Energy is moving on the surface here. And there's some energy that goes inside the interiors. These are called as body waves. These are called as surface waves. मुझे अगर इंटीरियर्स पढ़ना है तो मैं क्या पढ़ूंगा? Surface or body waves? Body waves, right? So surface wave is not our focus. Our focus is the body waves. ठीक है? But just for your information, surface waves can be two types. They are L waves and they can be R waves. L waves and R waves. L waves also called as love waves, R waves called as Rayleigh waves. Love waves and R waves. इन दोनों में से love waves are more dangerous because हाँ याद रहेगा, right? Love waves are more dangerous. Okay, stay away from that. ठीक है, एकदम spontaneously निकला है ना, एकदम हिस्ट्री okay, important है. Okay, एक हिस्ट्री है औरंगजेब का और एक अपना अपना हिस्ट्री है. Okay, so love waves are more dangerous, they cause more destruction, and body waves, these are of two types, P waves and S waves. So our study mainly is the body waves, P and S waves. Yes, Himanshu, I can understand. Your poetry tells me. बेटा पोइट्री ऐसे ही निकलता है. ठीक है, एक तो पोइट्री आपके लिए वेट कर रहा है आफ्टर प्रीलिम्स पेपर. ठीक है, वो भी एक अलग पोइट्री होगा. Okay, पर ठीक है. So fine. So we are more concerned about the body waves. Body waves are two types, P waves and S waves. So quickly, what are P waves? इसको ऐसे ही लिखो, okay? Don't have to add paragraphs here. And what are S waves? S waves are also called as secondary waves. S waves are transverse waves. P waves are primary waves. P waves also called as longitudinal waves. Examples of P waves are sound waves. इसका example है. P wave is not only earthquake waves, बाकी waves भी होते हैं. One type of P wave is sound wave. And transverse wave का example है. Okay. Or rather, say, let me rephrase it. One type of this wave is sound wave. And one type of transverse waves is the plucked strings of a guitar. When you pluck the guitar strings, वो जो vibrations होते हैं, they are examples of transverse waves. And sound waves are examples of longitudinal waves. You don't need more than this. Okay. Now, P waves का property ये है that their velocity increases with increase in rigidity of the medium. Their velocity increases with density of the medium. More dense, more speed of P, more rigid, more hard, also more speed of P. Okay. And the same thing is also true for S waves. S waves का भी यही property है. Their velocity increases with increase in density of the medium. It increases with increase in a rigidity of the medium. ये पार्ट दोनों का सेम है. One difference is that the P waves, these can pass through solids, liquids and gases. Okay. Whereas S waves cannot pass through fluid mediums. They can't pass through liquids, they can't pass through gases. S waves can't pass through fluid mediums. They can't pass through liquids, they can't pass through gases. What? Only solid. They can pass through only solids. This can pass through all the three mediums, solid and liquid and gases. S waves cannot pass through liquids and gases. You just have to remember this. Yes, correct. These are in your NCERT book also, but ठीक है, we are covering that. Yes. Yes, because वो solid ही है. मैं कहना solid, semi molten जो है, वो एक convenient word है. वो actual liquid थोड़ी है. वो अभी भी solid है, but it's a deformable solid. Okay. So yes. Your friend is asking me, can S waves pass through asthenosphere? Yes, because asthenosphere is a solid, but it is softer solid. But हाँ, because soft है, तो slow हो जाएगा. More rigid, more hard, more rigid, it'll be faster. This is the basic fact we needed. All the others to help you develop a concept. आपको इतना ही portion चाहिए. Okay, that to know the interiors of Earth, we study earthquake waves and we study the behavior of P and the S waves. P waves, this property, S wave, this property, that's all. आपको बाकी सारा कहानी नहीं चाहिए आपको. All fine here? Okay. Write down one short list of points लिखो आप. The P and the S waves, behave in the following way. They behave in the following way. Number one, they move fast when the medium becomes more dense. They move fast when the medium becomes more dense. Number two, they slow down when the medium becomes softer. They slow down when the medium becomes softer or the medium is less dense. Number three, the S waves will disappear. The S waves will disappear in fluid mediums like the outer core. Like the fluid medium, like the outer core. Next. In general, as we go inside the Earth, in general, as we go deeper inside the earth, the density increases. As we go deeper inside the earth, the density increases. So in general, both P and the S waves become progressively fast. In general, because the density of the earth increases with depth, both P and S waves in general become fast. Next. Because there is change in the medium and its density, because there is change in the medium and the density and its density, the P and the S waves bend as they pass. They bend as they pass. Within bracket, refraction. They bend as they pass. Okay. Since the density increases with depth, since the density increases with depth, both P and S waves, they bend outwards. Both P and S waves bend outwards. Okay? So this is the earth here, the earth here, and say this is where the earthquake wave starts. These are the interiors of earth, interiors of earth, interiors of earth. As it's passing, it becomes dense, more dense, more dense, more dense. In general, it increases. So the waves do not pass straight. While passing, they'll keep on bending, they keep on bending, and ultimately they come out. They keep on bending, they not pass straight, ऐसे pass नहीं करेंगे. They'll keep on bending, they keep on bending, and they come out. This outward bending is the consequence of increasing density and increasing velocity. Yeah, away from the normal, correct. What was that? Hello, Ravindran. Good afternoon. Yes, this is a live class. Okay, you have joined us right now. Happy to have you. Okay, we were talking about love affairs a few minutes ago. हमारा प्यार आपको खींच लाया शायद. रविंद्रन, ये डाउट क्यों हुआ बताओ? It's a live class. पहले बताओ आप इस बैच में एनरोल्ड हो या नहीं हो? मुझे पैसे मिले कि नहीं मिले? एनीवेज, आ ही गए हो तो पढ़ो. अभी गड्ढे में डाला है मैंने. विच बैच इज दिस? प्रियंका, इसको ट्रैक करो, जीपीएस लगाओ, ये कहां से आए हैं. जाने मत देना. प्रियंका. हाय सौरभ. बड़ा गंदा क्वेश्चन पूछ रहे हो यार. ओके सर, फी स्ट्रक्चर क्या है? अनमोल. ओके, अनमोल रतन टाइप्स. जितना पढ़ा रहे हैं पढ़ो, फिर देखा जाएगा. रविंद्र हैज गॉन, आई थिंक. हाय रविंद्र, यू कैन स्टे बैक. यू आर सीरियस? Okay, it is a live class. I am teaching geomorphology. My name is Shabbir. Okay, and this is geography optional class for UPSC. अब आप बताओ, तुसी कौन? Anyways, welcome. अभी गड्ढे में घुसे हैं, आप भी हमारे साथ आ जाओ. Studying the interiors of Earth, and how do we know about the interiors of the Earth? Okay, so maybe I've given some wrong access to some people. शायद आपका बैच हो चुका है. Okay. चलो कोई नहीं, इट्स ओके. अब आए हैं तो पढ़ के जाओ. So पूरा हिल गया मैं यार, Okay, so discussion was that as the density of the medium increases, the path of P and S waves will change. And the change कैसा है? Change is P and S waves, they bend outwards. आपको ये याद रखना है. Some things we just remember, okay? This is one of the evidences that when they're bending outwards means the density is increasing. Okay? Next slide down. Other observations of P and S waves. Other observations of P and S waves. Just know one fact, ये question prelims में था. The P waves, they move faster than the S waves. The P waves are faster than the S waves. This was a prelims question last year. Okay. Just know this, a property hai, so we remember this. Okay. Now, what are the other observations? I'm discussing in a tabular form. आप भी वैसे ही बनाओ. Make a table, maybe a smaller one on the left hand side and a bit more bigger, say maybe 1/3, 2/3 types. Okay? So यहाँ पर थोड़ा ज़्यादा लिखना पड़ेगा और यहाँ कम लिखना है. What are the observations? Okay, 1, 2 and so on. Yes, exam में भी इसको ऐसे ही लिखना. Okay, because if you write too much of, एक तो ये पूछेगा तो ये शायद 10 मार्क का ही पूछेगा. 10 mark means you can't write more than 1.5, 2 pages, which means you can't write everything in paragraphs. So this part of the answer table में लिख के आ जाना. No problem. Yes, correct. Okay, what you can see is, okay, the initial classes live for you. Okay. The observations number one, initially P and S waves are very slow. Number one, initially the P and S waves are very slow. Okay, P waves have a speed of around 5 kilometers per second and S waves have a speed of around 3 kilometers per second. So P and S, they are very slow. P wave ka speed is 5 kilometers per second and S wave ka speed is 3 kilometers per second. Okay, this is the observation, this is the inference. Okay, the velocity corresponds to granitic rocks. The velocity corresponds to granitic rocks. And the PS waves are called as PG and SG waves. It corresponds to the granite rocks and the waves are called as PG and SG waves. And then add here that after a depth of 30 kilometers, the P and S waves start becoming faster. After 30 kilometers, the P and the S waves become faster. Why? Because remember, 30 kilometers corresponds to what? The Conrad discontinuity. The upper layers are less dense, the lower layer becomes a bit more denser. So 30 kilometers corresponds to the Conrad's discontinuity. Okay, because after 30 kilometers, the rocks in the continents become a bit more denser. They are a bit more mafic compared to the upper felsic. Okay. The second observation. While crossing the Moho discontinuity, P and S waves pick up speed very fast or pick up speed suddenly. While crossing the Moho discontinuity, the P and S waves, the pick up speed, okay, suddenly. The P waves become as much as 7 kilometers per second. 7 kilometers per second. ठीक है? Inference में, okay, beyond the Moho is the mantle with higher density. Most books don't mention it. Okay, S around 5 या 6 होता है, तो यहाँ पर दोनों जानो, इसके बाद में P से ही we will manage. Okay, so beyond Moho, it is the denser mantle. Density increases to more than 4, more than 5. It is denser mantle. ठीक है? Third, at 100 kilometers depth, there is a sudden drop in P and S wave speed. At 100 kilometers depth, there is a sudden drop in the P and S wave speed. Okay. P wave का जो velocity है, it drops from 7.8 kilometers per second to about 7.3 kilometers per second. There's a sudden drop in speed. Okay. And for P waves, the speed fall is from 7.8 kilometers per second up to 7.3 kilometers per second. Sudden drop हुआ. Inference में क्या है? Okay. Beyond 100 kilometers is the asthenosphere. Which is dense but is not very rigid. Beyond 100 is the asthenosphere, which is dense but is not very rigid. वो hard नहीं, it is semi-molten. All fine? Thank you. The next, beyond 350 400 kilometers, the P and the S waves consistently increase in speed. Okay. Why? Because, okay, the middle mantle and the inner mantle, are very dense. The middle mantle and the inner mantle are very dense. The density is about 7 to 11. याद आ रहा है आपका? Density is about 7 to 11 in the middle and in the inner mantle. ये ऐड कर देना that the speed increases to the speed of P waves increases to 11 kilometers per second. The speed of P waves increases to 11 kilometers per second. Beyond 900 kilometers depth. Beyond 900 kilometers depth. Why? Because beyond 900, क्या है? It is the inner mantle. Okay. So the inner mantle, because it has high speed, it's also called as high velocity zone. Because beyond 900 kilometers, is the inner mantle. And the inner mantle has, reference में. And the inner mantle has, inner mantle is called the HVZ, high velocity zone. It's called as the high velocity zone. वापस ऊपर आ जाओ, जहां पर लिखा है आपने एस्ट्रोनॉस्फेयर लिखा हुआ है ना, एस्ट्रोनॉस्फेयर beyond 100, because the P and the S waves, they become slow. The astronosphere is also called as the low velocity zone. The inner mantle is called as high velocity zone, and the astronosphere is called as the low velocity zone. It's called as the low velocity zone. हो गया आप all done till here? Okay, now move on. Next one. The next one is beyond 2900 kilometers. Beyond 2900 kilometers, the S waves suddenly disappear. Beyond 2900 kilometers, the S waves suddenly disappear. Inference में why? Because of the fluid outer core. S waves can't pass through liquid mediums because of the fluid outer core. They disappear. Now, यही चीज को, I'll show this in the diagram form, so you remember this now. The core, and say I'm taking up maybe this part of the earth, and this part has a continent, it has an ocean. Okay, so waves कैसा है? The waves are slow here. The waves become fast here. The waves become very, very fast here. And after this, the waves again become slow here. Then again they have become very, very fast. The thick line shows the speed has increased. Okay? So this is 1, this is 2, this is 3, this is 4, and this is 5. 1 में क्या हो रहा है? 1 में it is slow because granite है. Granite is less dense. 2 में it is becoming faster. Why? Because this is beyond the Conrad discontinuity. 3 में it is very fast. Very fast because this is beyond the moho. 4 is sudden slow because this is the asthenosphere, the low velocity zone. 5 में again very fast. In fact, when you are coming to beyond this one, यहाँ पर तो it's extremely fast. So this is the middle mantle, this is the इनर मैंटल, ये है एस्ट्रोनॉस्फेयर, ये है लिथोस्फेयर, एंड दिस बाउंड्री इज द मोहो डिस्कंटिन्यूटी. दिस इज मोहो. Make sense, all of you? You can draw if you want to draw, that's your choice. तो इसमें कुछ memorization blind नहीं है. If you know the layers, you're on. Deliberately, I am showing you a thin line here. Then I am showing you slightly thicker line here. Then I am showing you more thicker line here. Suddenly, again, less thick. Then again thicker. And this is the thickest. इतना समझ में आ जाना चाहिए आपको. One is the slowest. 2 becomes faster. 3 becomes even more faster. 4 sudden drop. Then building up speed. And very, very fast beyond 900 kilometer. Remember the values here. This is 900. Okay. This is, say, 40 kilometers. This is 100 kilometers. This is 30 kilometers. अगर आपको layers याद हैं, उसके बाद you don't have to memorize anything. As it becomes denser, it becomes faster. Astronosphere is also called as the LVZ, and the deep mantle is also called as, okay, HVZ, high velocity zone and low velocity zone. Any doubts in this? Anybody? Yes. कहीं भी हो सकता है. Okay. I'll come back on. All of you done with this? याद हुआ कि नहीं, all of you? That's our my bigger concern. And whatever I'm telling you, आपको लिखा भी रहे हैं. Okay. Yes. Because ये dense बढ़ जाता है यहाँ पर. Okay. The speed depends on the density. Okay, it's like you are swimming. अगर पानी का स्पीड उल्टे में ज्यादा है तो आप स्लो हो जाओगे. अगर पानी का स्पीड उल्टे में कम है तो आप स्पीड पिकअप करोगे. Okay, so the speed of the waves depends on the medium density. Okay, इतना याद रखो and we're on. Essentially vibration है. जितना पास पैकिंग होगा उतना ज्यादा वाइब्रेशन उसका मूव करेगा. जितना दूर दूर रहेगा वो एनर्जी पास नहीं कर पा रहा होगा. ठीक है. Slow because of granite. We call this as PGSG waves. Okay, your friend asked me, so ये earthquake wave का focus कहाँ है? Listen, Earth is here. Earthquakes can be anywhere. कहीं भी हो सकता है. और हर earthquake waves में we'll have this PNS waves. मेरा purpose क्या है? My purpose is I want to study the interiors of Earth. So I pick up that earthquake जो सरफेस के सबसे पास में, हम इसको उठा रहे हैं. आई एम नॉट सेइंग कि earthquakes नहीं है. मुझे वो लोकेशन चाहिए from where the waves can pass completely. So I'm picking up that earthquake which is nearest to the surface of Earth, ताकि I can know the entire passage and how the velocity is changing. अब ठीक है? How to measure मतलब? हाँ, वो क्या इंस्ट्रूमेंट है वो हम छोड़ देते हैं जियोलॉजी पे. That part is geophysics. Essentially, how do I know यहाँ कितना स्पीड हुआ? How do I know यहाँ कितना स्पीड हुआ? Okay, so कोई अल्ट्रासाउंड मशीन होगा. So that part of physics is beyond geography, thankfully. ठीक है? वो geophysics अलग है. We only study inference क्या है. जब हम जाते हैं as a layman, कि अगर किडनी में पत्थर है तो निकाल के काट के फेंक दो पत्थर को, राइट। अब कैसे पता चला पत्थर है, कैसे ऑपरेशन कर रहे हैं, वो छोड़ दो, डॉक्टर पे छोड़ दो। एज ए लेमैन आई नो कि अगर पत्थर है काट के निकाल दो, बिकॉज इट्स अ कैंसर, आई लव कीमोथेरेपी, इतना पता है लेमैन के तो, राइट। कैसे करना है, कहां करना है, वो काम डॉक्टर का है। सो इन ज्योग्राफी वी ओनली रिलेटिंग कि हाउ आई नो द इंटीरियर्स, बट द मैकेनिज्म ऑफ स्टडीइंग द डिटेल्स वी स्किप दैट। यस, वेव बेंड क्यों हो रही है? अच्छा ठीक है, ओके। अदर्स इफ यू डोंट राइट डाउन, क्यूरियोसिटी है तो आई विल ट्राई आंसरिंग दैट। You all, I hope you know about light, right? ये normal है. This is air, this is water. How does the light bend when entering from air towards the water? Towards normal. ये ऐसे, it should have passed straight. It bends towards normal. Why? Because speed of light is more in air, less in water. Okay. Because speed of light कम है, so light must pass less distance ताकि उसका स्पीड मेंटेन रहे। ठीक है, अगर ये पाथ चलेगा तो क्या होगा? इट्स मोर डिस्टेंस, राइट। स्पीड यहां पर 10 है, यहां पर भी 10 है। ओके, सो टू मेंटेन द सेम स्पीड वो अपना पाथ छोटा कर लेता है ताकि यू नो दिस डिस्टेंस इज लेस। सो इन केस ऑफ लाइट, वाटर हैज more density, and in water the speed of light is what? More or less? It is less. It slows down, so it takes a shorter path ताकि उसका स्पीड मेंटेन हो जाए। In case of PS waves, okay, say this is a P or a S wave, ये आ रहा है। This is medium 1, this is medium 2। ये लाइट वेव नहीं है। लाइट में क्या है? लाइट में the speed becomes less if the medium is dense. In this case, the speed becomes more because the medium is dense. तो यहां पर rather than bending inside, it will bend outside. अब समझ में आया? So this is the difference between the mechanical waves and how light waves behave. लेकिन दोनों में bending है। The moment the medium changes, the speed will change. अब depending on कि speed बढ़ रहा है या घट रहा है, bending is outward. So when you come here, the speed of light increases here. So यहां पर क्या होगा? It is moving away from normal. So when inside the water it moves towards normal, away from water it moves away from normal. यहां पर उल्टा हो रहा है। Inside the dense medium it moves away from normal, इसमें आएगा it move towards the normal. So अर्थ के केस में layer 1, layer 2, layer 3, energy is coming from here. This is the medium. It will bend outward. This is the normal. It will further bend outwards. This is the normal. It again bends out. ऐसे चला जाएगा बाहर. If the density was increasing, then bend inside, then bend inside. ऐसे होता. तो इसके जो डिटेल्स हैं, I mean, बहुत वेरिएशंस होंगे, but we just write one statement that as the speed of as the density of the medium increases, the waves keep on moving outwards. ठीक है? नहीं, they are two different waves. S waves and P waves are from earthquake. Don't say S waves are from P. Don't say that. Okay. ये दो waves आते हैं from the earthquakes. Okay, let me just put in the last word on this. Then I'll continue tomorrow. I hope you have taken down the list and you have answered diagram. इस समझ में आ गया आपको? Okay. So back to a table. Back to a table right down. Okay. That beyond 2900 kilometers. Yeah, next point. A table में continue करो. Beyond 2900 kilometers, the P waves continue, but they slow down. Beyond 2900 kilometers, the P waves continue, but they slow down and bend inwards. They bend inwards before again bending outwards. Again bending outwards. They first bend inwards, then they again bend outwards while passing through the inner core. While passing through the inner core. Inference में the outer core is fluid. Inference में the outer core is fluid and the inner core is very dense and solid. The inner core is very dense and it is solid. So this was the core. I said the S waves, they keep on bending outwards. They keep on bending outwards. They hit the outer core tangentially. They move outwards. इसके बाद में the S waves can't pass. They keep on bending outwards. They keep bending outwards. They become tangential and they move outwards. But इसके बाद में they can't pass. This is how the S waves are moving. Okay. For P waves, for the P waves, they again bend outwards, they become tangential and bend outwards. यहाँ पर क्या होगा? They hit here, they first bend inwards, then they again bend outwards, they again bend inwards. ऐसे होकर they ultimately will come out here. So there are a series of, refractions. You need not show all the details. Just show this as bend inwards, then outwards, inwards, ultimately they come out here. So unlike P waves, unlike S waves, जो पास ही नहीं करते हैं, P waves पास करेंगे, but lot of modifications here. Which? They might be interacting. अब क्या हो रहा होगा? Details even I do not know. So you need to draw two diagrams. This is the diagram for S waves, and this is a diagram for the P waves. The S waves diagram and the P waves diagram. All fine? Fine, then we'll continue tomorrow. Yesterday, I think it was a miscommunication. The new students should know this. Every Tuesday and Wednesdays, we have case studies. Case studies takes about 10-15 minutes. कल भी था case study, but somehow I got the wrong message कि नहीं है. So the case study also goes live on the YouTube. Okay, case study आज भी है. Priyanka, I hope it's confirmed, right? So my suggestion is we have the case study at 2:30. Stay back for 10 minutes, and the old students know what we are doing. The new ones, okay, these are parts of your learnings. Without the case studies, you cannot do many things. And the case studies need not be exactly what is being taught as a part of foundation. Yeah, Priyanka, yesterday we made a mistake. Okay, it's not a technical. Basically, we take up one place, one event, and discuss some details around that with a map, with some discussions and facts. So for all of you, you maintain a separate notebook of case studies. The case studies of population, migration, environment issues, development issues, rural development, okay, case studies of earthquakes, of tsunamis. ठीक है? आप एक अलग से बना लेना notebook. ठीक है? So I will take leave. Ajay sir will take on from here. Take 15 minutes. Yeah. Fine. You can log off and log in on the case study link, online students. And offline, okay, you can sit through and finish the class. Okay. Bye-bye all of you. Priyanka, are they having a separate link for a case study or are they watching on the YouTube? Same link. So do I switch off or not? I switch off, right? Yes, okay. So guys, or online guys, log back again on the same link after 2:30. I'll let you know, Priyanshu. I'm just catching my breath. I'll let you know. Okay then, bye-bye all of you.